Hello everyone. Today we'll be taking a look then a little bit into Runit, which is the init system for Void Linux. I've been dealing with it for like a few days. I think I installed this Void Linux system 2 weeks ago. So I'm still working on it. I'm still adding a few stuff, a bunch of stuff actually. And I've been trying to understand how Runit works because some of the services that I want on my system, they are not installed there by default. So in some cases, depending on what kind of tool you're using, you'll be needing to write a bit of Runit, let's say units. I'm not necessarily sure this is the right term, but just like in systemd, you have units which are essentially the baseline to make your service. You have the same thing in Runit, but the way in which you define things and the way in which you start services is different for Runit. So while in systemd you would have a kind of a config file, and you would have sections and you'll have parameter set. Essentially in Runit, whatever it is that you can start with a bash script, the idea is that you can make a script in bash and you can start a service, and then Runit takes it from there. So you just need to really make a little script that starts your daemon, whatever it is that you're doing in the background, and then you just pass it over to Runit, and Runit can monitor it and can give you data on it. So if we go to the Runit page, actually had it open, but whatever, you can see that Runit is a cross-platform Unix init scheme with service supervision and a replacement for sysv init. What's interesting about it is that it's its simplicity once again. Due to the fact that it's really simple, it manages to be very fast too. So I just installed this machine. I put a bunch of stuff into it, but I'm taking about 4 seconds to get from the BIOS screen to the login prompt, which is relatively fast. I mean, I'm running on an i5 I think processor. I really don't have that much in terms of RAM. It's a rather old machine, and yet it holds pretty well booting, thanks to the init scheme part, I would say. So let's get to take a look at how then we can set up services, how we can take a look at how services work in Runit. So I'll be starting a terminal, and then let's start by talking about this. So the way in which you manage your systems, your services, on Runit is essentially you manage your systems by means of a special folder on your file system. And what I mean by that is, if you go to the folder var service and you do an ls, you see that you start finding a bunch of symlinks. And the idea here is that whatever it is that you symlink here, it's going to be interpreted as a service, and it's going to be enabled using systemd terminology. So enabling a service means that you're going to start it at boot time. So all the services that are here, unless in some edge cases, most of the time they are going to be started at startup. Okay, so we can check, you can do an sv status. This is how Runit calls its this is how Runit checks the status on a program. So if you do an sv status network manager, say, you just need to enter my password. You can see that it's running. So Runit gives you information on the process. It says that it's running. It gives you its PID. It gives you as well for how long it has been running. So this is since my computer started. And as far as monitoring, that's all that it does. It just checks if the process is alive. It reports on its speed, and it reports on the uptime. And just like you would do, say, for systemd, if you go, for example, the way by which you manage services in systemd is obviously systemctl, and just like you can do a systemctl start, you can do an sv start in order to start the service. So right now, let me take a look at the service that I did, which is an Emacs server. You can see that it's running right now. Here it's the PID, and then what I can do is I can also stop it. And you can see that it's down. It has been down for 0 seconds. We just killed it, and you know, before I would be able to connect to this server, to the Emacs server using, for example, this command, an Emacs client. Now you can see that it's not able to see it. However, if I bring my daemon up, it brings it up, and then I can just do the same thing, Emacs client, and see, and now I can get to my editor. So we'll see later how this works. This is actually a custom-made service that I made because essentially Emacs, when you install it, it doesn't really come with a Runit unit, let's say it this way, so that I can start it at startup. So I had to make my own, and it's really simple. I will show you later how to do that. But this is the basics of SV. So you have the SV program that you use just like you would use a systemctl. So you know, you can ask for status on a program, you can start programs, you can stop programs, you can obviously also restart them. And and another important thing is that whatever it is that you symlink inside of our service folder is a service that you are, say, enabling so that it starts at boot time. This is important. And if we take a look at this folder, which is /sv, if you guys are using Void Linux, you can see that this has quite a lot of stuff. And what happens is that whatever it is that you make an XBPS install, so let's say that I want to install Network Manager, for example. What I would do is I would do an XBPS install as and then you would do Network Manager, and then the idea is that whenever you install a program that requires a daemon, it will normally also come with its own Runit service. So it will actually insert a new Network Manager folder corresponding to the program that you installed. This is the basic. So if you want to enable any of these services that are here, you just need to do something like this. You do a symlink between the folder that you want to link. So let's say I want to do something for MPD. I would symlink it like this to our service, and that's it. From the moment that I symlink it, I'm actually enabling the service, and normally it will start instantaneously. You can also set it to stop to start down, as in not to start it as at boot time. You just need to work with a specific file that you need to put on the service. But this is for later. Right now, the last thing that we have to do before we get to custom services is essentially understanding what services look like, what is the file structure for these folders that we're linking. And for that I actually made my own service. I put it here. You can see that it's the service for the Emacs server I was talking about. So if I make a tree edit, you can see that there are a few things. Essentially the file structure is always the following. The simplest service you can do, it actually contains a run script, and then Runit actually inserts a few extra stuff. This is the simplest you can put. Right now ignore this part because this is just used for logging. For now, a simple service would be making a run script. This is just a bash script, and then you can create or not a supervised directory, which is what Runit uses to manage. And we can even get into that directory. I can do, for example, I can get the PID. You can see that I have the PID here. Oops. And what's important here is that this is how Runit gives you information on the process. So it has whenever you do an SV status, Emacs, sudo. Essentially what it does is it looks inside the supervised folder of your service, and then it just, for example, it puts the PID, whatever is inside this file, this kind of thing. So status and they are actually binary files, I believe. You can't really read them. Stat gives you whether or not it's running, but status, you can see that it gives you some gibberish, doesn't really matter. But essentially they have the information that Runit needs to give you, just in case you ask for it. And that's the gist of it. So if I want to take a look at how a run script works, I'll open up Emacs. We can go to opt sv Emacs run. You can see that it's a very simple one actually. Let me put this in full screen. So what you have here is you have the shebang, obviously it's a shell script, and then you have an exec statement. And the gist of it is that you always need to run this exec. It essentially is something that if you look at the docs for Runit, you most likely would always want to use. And then the idea is that to this exec statement you would give a bunch of parameters that will in the end start your program. So you know, it gives you a chpst, and we can actually check the manual for that chpst. If you take a look at the manual for that, it runs a program with change process state. That is to say, it will run your program as root, but then it will actually, what it will do, it will change the parameters of the program. So you can see that if I do where up, you can see that if I do a sv status Emacs once again, I have the PID, I have the stuff, whatever, but what's important is that I have the PID. I can do ps-aux, and then I can grep for this PID, for example. You can see that the PID of this process, it actually belongs to me as a user. So you know, it's not root who started this, who manages this process. Which means that if, for example, if I wanted, I could just kill it as is. I wouldn't need to run sudo for that. This is the idea. When you do a chpst, let me go back. Where up? If I go back to my script, essentially that's the idea. So I'm changing the status of the process. You can see that I'm giving it the -u option, which is specify a user. It's this option here. And then this does exactly what I told you. So it changes the process ID of the process, of this one process in particular, to be my user, so that I can manage it myself. And then once you run this, you actually give it another program, and this other program that it calls is actually the one that's really starting the Emacs server. So here we have Emacs-u. This is just so that it will read my configuration, and then it's important that you start it as a foreground daemon. Emacs actually has two options. Version 26 dot something added this one that's for a foreground daemon, because the idea is that Runit, when it starts your process, it executes this script, and then it keeps looking at the standard output of the process, and then through that it is capable of telling whether or not the process say failed, and it's also capable of keeping logs on what the process outputs. So you really want to do a foreground daemon, because otherwise Runit can't really manage your process. It will just go away, and it won't be able to do any logging, and it also won't be able to know whether or not the process executed successfully. So if you're thinking of making a custom process, just make sure that you can make it in a foreground daemon, so that Runit can have access to the standard output of it. And the last thing that I do, I just do a redirection. So to redirect to one, these are the file descriptors for standard error. What I'm doing here is I'm redirecting standard error inside standard out, because again, by the Runit specification, this is how you should do things, just so that it has access to both the streams. It has access to the error, standard error, as well as to standard output. This is just good practice, so that you have information on your logs if anything goes wrong. And speaking of logging, that's the next thing we'll be taking a look at. So I told you before, let me go back to my shell actually. I'm at this directory. If I showed you earlier, this is the file structure. So you have a run script which contains the things that I showed you earlier. It's just a bash script that starts your service. And then what I also did is I added a second subdirectory to my directory, which essentially contains information on logging. So the idea here is that you create a second daemon that works in parallel with your main one, and the second daemon, it essentially saves whatever it is, the standard output of your program, into a file so that you can have access to it. If I go inside the log directory, you can see it also has a run script. I won't really do that, but I could. And here, if I just get it, you see it's another bash script. It starts with an exec statement. It starts with the same change process status. It changes it to my user. And then what it does is it calls not another program, but it calls the svlogd. And if I ask for a menu for it, you can see that svlogd is Runit service login daemon. So the idea is that Runit starts your service using the bash script you gave, and then it looks at and then it redirects all the standard output inside this login daemon, and then this login daemon, it will process it however it can, however you specify, and it will output this to a file. You can see it output this to a log file, and then you can give some options. The options that I gave on my script is the /tt. This stands for timestamp. If I go down, you can see that I can set timestamps to my logs just so that they are easier to read. And then I specify this one file here. So if I go to opt logs Emacs, you see I have a current, and this contains essentially all the logs for my Emacs service that I did. So this is essentially how you would go about managing service. We've shown that you can manage service using the sv command. It works similarly to systemctl in that you can stop, start, restart, and get the status information on a process. And then we saw that you can go to a special folder in your file system called var service, and the idea is that whatever it is that you symlink here is going to become an enabled service, so it's going to start a startup. We've also shown that if you go to sv@csv, most of the programs that you install via an xbps install will that need a daemon, they will essentially install their daemon here, and you just need to remember to symlink whatever it is, for example this tty1, and you just need to remember to essentially symlink them back to the main folder. So you would do something like this, and this would be equivalent of doing a systemctl enable and then your unit name. What else? After that, we essentially looked at how the file structure for one of these is. So if you do I can't really do that from here, but I can do that from opt sv. You can see that if you need to make your own custom service, all you need to do is you need to make a folder for it somewhere in your file system. You make a script called run for it, and then this script will essentially is essentially a simple bash script that you use to start the program you need with the parameters you need. If you want, you can set it to your specific user using this, and then you also need to make to pay attention to start it always as a foreground daemon, and also to redirect your output stream so that you have them all in one place. And yeah, that's it. Um, Other than that, I think this is a fairly good beginning, and it should be put you well on your way to start whatever to write whatever it is you need in terms of service. So thank you for watching, and I'll see you next time.